Okay, as you can see, we're back to this problem, which is why this one's called Problem 2B. Because we're still working with that same problem, this time with the proper number of ones in the problem, no extra one added this time. In the last video involving this problem, I said that you can solve these problems two ways. You can either use your grouping symbols like we did in the other video, or you can put it in PEMDAS order. Now normally that gets very murky and muddy and convoluted if you do that. This one happens to work out cleanly, and so I realized I didn't even show you the other way to do it normally, because it normally comes out so hard to do it. This one works out pretty cleanly though, because the only thing we have to move, if you remember correctly in the other problem, if you have not seen the other video on this problem, link in the description, please go watch it, because I'm going to refer to it several times. You see we just moved this 1 times 0 from when it was down here up to here. The reason we do that is because this operation is supposed to be performed first. So we now have this in order where we can just go left to right. And like I said, a lot of problems, it gets really muddy when you try to do this, but this one happens to work out pretty cleanly. So we can look here, use fuchsia. We can say, okay, we have 1 times 0. Get 0. And then we add all these ones in, and there are actually 12 of them this time and not 13. You got your 1 plus 12. I'm sorry, your 0 plus 12, because there are 12 ones, and we know that 1 times 0 is 0. And that gives you 12. Now, I know some of you are probably screaming, hey, you changed the problem when you move this up here. Visually, yes. Mathematically, no. The problem that would still be worked in this order. This is just a way to see it left to right, which is the tempting way for people to work it anyway. So I'm just kind of trying to bring that visual to you and see if maybe, make it a little easier to see that this operation goes first, and that this times 0 only affects this single 1. Again, you see we got the 0 here. We have a number and an ending. And then we have a 0, and we have another operational symbol. Again, nothing to show us that this multiplication pushes out past that operational symbol. Nothing to tell us that it does not bind just these two numbers together. Again, the author could have put parentheses in and made the problem look like, let's say, that. Well, then you've got a little bit different. See, now that we have these parentheses, if the author had written it this way, very important note, this is not the way it really looks, then we know that this multiplication affects other things. It can push farther out. So you have 1 times 0 plus 1. Again, though, it's going to come out to be the same, just simply because we're dealing with ones and a 0. But if this wasn't a 0, if it was a 2 or something like that, you could start actually, and if we have more than just the ones, it could start to change things up. Again, inside these parentheses, since we have multiple operations, we still have to follow PEMDAS and do our multiplication and our addition. And again, because we're dealing with ones and zeros in this little binary problem, it's not going to make a difference. It's going to come out the same. But, it could, if we were dealing with a wider range of numbers, especially if we didn't have that 0 in there, which is going to make a lot of stuff come out the same. It could really start to change things up. So, like I said, if you haven't seen the original video on this problem, link in the description. Please go watch it. Since I referred to it several times, it might make things a little clearer in this video. Again, any questions, you can put them in the comments. And thank you for watching.